Hello and welcome back. After a short hiatus, we're back with the next season, season 6 of Coffee Break, where we take 20 minutes out of our day, maybe have a cup of coffee, and talk about trending topics and ideas of interest. I hope everybody's got their cup ready. I will admit that this morning I cheated. I stopped and bought my coffee on the way in rather than brewing it fresh. But that's kind of life these days, is you got to do what you do. And but I hope everybody's got their coffee ready to go. The other thing I will point out before we start is I had Wardrobe whip up some special coffee socks. So in honor of the 6th season and the start, I will be wearing my coffee socks from now on for Coffee Break. So I'm sure that thrills everybody. So, but welcome back. It's good to have everybody with us. Long-time viewers, new viewers, both heartily welcome to the show. So today we're going to be talking about microcontrollers again. It's something that Microchip is obviously very well known for. And joining me today in studio is Ulysses Iniguez from our MC8 business unit. So
thanks for having me.
And this is a first, I believe, for Coffee Break. We have a second guest joining us from the birthplace of AVR in Trondheim, Norway, is Stian Sogstad. Did I get that right? Sogstad?
Perfect.
Just the perfect accent. I got it down. All right. So we're going to tag team you a little bit today with the content. We'll start with Ulysses. With some of an overview of the product line, and then we'll have Stian dive into some of the details. But before we get started, as always, we will go to the booth. To Austin is in there, I believe. Austin, you in there?
Yes, I am.
All right. Can you tell our friends how they can participate?
Absolutely. Happy to be back, Ross, for Season 5 here of Coffee Break.
Season 6?
Season 6, I'm sorry.
Season 6.
Goodness, I need my, oh, it is? Okay, gotcha. And as usual, we're broadcasting live on LinkedIn, Facebook, and YouTube, and our experts are standing by in the chat to field your questions. Now, if you do prefer to submit your questions via email, you may do so at livestream@microchip.com. Once again, that's livestream@microchip.com. And don't forget to like and subscribe here to our YouTube channel, as well as following our LinkedIn to be the first to know about all things Microchip and Coffee Break. Back to you, Ross.
Fantastic. Thank you. Thank you, Austin. All right, so let's get started with today's topic. You know, microcontrollers are obviously something that Microchip is very, very well known for, and we've got an extensive portfolio. But increasingly, we're starting to develop products that are aimed at some of the emerging markets and some of the emerging applications. And obviously, IoT is no longer an emerging application, it's everywhere. But one of the challenges of IoT has always been the sensor interface and collecting that information and bringing it back in. So the ATtiny family is one of the families that we've got that is aimed at that particular market. Could you sort of walk us through sort of the high level of the product line and the features, and then we'll kick it over to Stian to talk about some of the applications.
All right, perfect. Let's get started. So the ATtiny, or the ATtiny1627 Tiny 2, is our new and third member of our Tiny AVR portfolio, and it's used for high precision analog measurements. It has superior noise suppression and fast acquisition time, which makes it ideal for noisy environment applications. And like our other products in our portfolio, it is code efficient and low power.
So let's look at some of the family and some of the other members that went before this one, and what makes the 27 so interesting.
All right, perfect. So as you can see here in this graphic, in the middle is our Tiny Zero, so it's our basic feature optimized family. To the right we have the Tiny 1, which has everything the Tiny Zero has, but with a touch controller peripheral. And to the left we have our Tiny 2, and it has listed all the features, but the main feature is the 12-bit differential ADC with a PGA.
So those of you who have been with us before, remember back in season 5, we spent a little bit of time talking about A to D converters and the benefits of external versus internal. This is one of those internal, but I think one of the things that we're starting to see is that performance level starting to creep up on the internal.
Oh, yes.
Some of the trade-offs we used to make were between performance and cost and size. That's starting to converge a little bit, and I think we're starting to push up that chain a little bit. So with a little bit of the detail on the actual performance and specs, let's turn it over to Stian. And Stian, would you walk us through the details?
Yeah, sure. Thank you, Ross. So the Tiny 2 is as the name described, one of our smaller microcontroller families. It is available in 4 to 32 kilobyte of flash, and it comes in 14 to 24 pin packages. And one of the more popular packages on the Tiny is the small 3x3 millimeter QFN package, which is definitely the high runner for these small micros. And it's available in standard and extended temp grades as well, and will be available for automotive later this year. Like Ulysses said, the 12-bit differential ADC with computational capabilities, like oversampling and averaging, is the main differentiator here, together with the built-in programmable gain amplifier that can amplify the signal up to 16 times before it enters the ADC for conversion. In addition, the Tiny 2 also features the event system, which enables peripherals to communicate directly with each other without involving the CPU, something that will make a more responsive system and a responsive and deterministic system, since the CPU can either stay asleep or do other tasks. We also have the configurable custom logic, which is a programmable logic peripheral that eliminates the need for having external logic on the PCB, something that can help customers reduce the BOM cost and board space, which is often key is these small space constrained applications.
So we've talked a little bit already about the 12-bit differential ADD converter, and I think that's the critical part of, I mean, it's a great part, but that's the critical part that makes it such a great sensor interface component. Is that true?
That is absolutely true. So this family was actually designed with sensor and nodes application in mind. And here we have a rough graphic illustrating how this can be used. So here is the 1627 used inside a sensor node. It can be connected to any type of sensor, for example, a PIR motion detection sensor. The data collected from the sensor is then input to the ADC. The signal might be very small and noisy, and therefore needs to be amplified by the PGA before it goes into the ADC for conversion. This gain amplifying is often using external operational amplifier or op-amps, and the PGA can then help also reducing the bill of material on such an application. The output of the ADC can then be transferred through the serial communication interfaces to a Bluetooth chip or Wi-Fi chip, and that way be connected to the sensor networks itself. Another good application for the Tiny 2 is as a companionship to a larger system. So it can be as a safety monitoring device connected to a larger MCU or MPU, or just doing smaller housekeeping tasks while the bigger MCU manage the main application tasks. These are just a few examples where the Tinys can be very useful.
So in looking over the literature to the part, one of the things that jumped out at me was its applicability for functional safety applications, which is something we're seeing more and more of, especially in the automotive space and elsewhere. Can you talk a little bit about that?
Absolutely. So to accommodate the need for functional safety in different industries, we have made sure that all our new products are released as what we refer to as functional safety ready. This means that we have FMEA reports, we have safety manuals, and we have certified compiler and certified tools to support this. So this doesn't mean that the device itself is certified, but it's there to help customer get their end product certified, and that could be according to different standards like ISO 26262 for automotive, IEC 61508 for industrial, and IEC 60730 for appliance products. And of course, we have experts to help our customers with this, that are dedicated to functional safety. So all requests for safety manual and FMEA reports and such can be handled through NASCAR, so-called non-standard customer action requests, which are things you need that are not available on default on our website.
And those NASCARs can be accessed through the website?
Yes, so so contact your local microchip representative, and they will help you out there.
All right, excellent. So, how many other standards have you memorized? Just out of curiosity, how many other?
Yeah, that's a good one. I can admit I had a post-it to help me there.
All right. So,
and luckily we have the experts handling that part.
Too many to keep track of anymore. So, as with all microcontrollers, one of the key elements is not just the part itself, but the tools and the software that go with it. Is to be able to actually implement it, you need the development platform. So, Ulysses, why don't you tell us a little bit now about that platform and what's available?
Yeah, so the Tiny2 is supported by both Microchip and classic AVR tool chains. So that includes MPLAB-X and Studio IDEs, as well as GCC and XE8 compilers. And the XE8 compiler has a functional safety license portion. And to help you get started, we also have MCC and Start. Those are our code configurators, and we have plenty of code examples on GitHub. And all our code examples are also listed in MPLAB Discover tool that can be found at microchip.com/discover. And we also have development boards, programmers, and debuggers to help you out.
And those of you who have been longtime viewers will remember that we talked about MPLAB Discover back in one of the first couple of episodes of last season. So you can go back into the library and find out about that if you missed that episode. So, all right, so there's tons of information on the website for these. So why don't there's data sheets, there's video, there's all kinds of stuff. This information will be posted on the site so that you can access it after this is over. But do go look, do go see what's out there. There's some great information, and it's a great little part. So that kind of wraps up this part of the discussion. We will now turn to Austin in the booth for questions.
Absolutely, Ross, and we certainly do have some good engagement from our audience. Keep that up. Our first is going to come via email, and that's going to be, how about availability? Is the Tiny2 ready to order?
Yes, the Tiny2 is available to order now, and it's available from 4 to 32 kilobyte, and it's also available in Curiosity Nano development boards.
Awesome. Thank you, Ulysses. And our second question is coming from John Billingsley. Is the ATtiny1627 supported by functional safety libraries?
Yes, sir, it is. It's supported by Class B library for now, and more to come. So.
Awesome. Thanks, guys.
Partly yes.
Thank you, Stian. And our second question is going to come via email as well. Do we have any training material or videos that can help customers get started?
Yes, so on our YouTube channel, we have family overview videos, special features on our 12 differential ADC and PGA, as well as hands-on training and code examples. Just search for ATtiny1627.
Perfect. Thanks, guys. We do have another question here from Dr. Ing on LinkedIn. That's going to read, does Microchip have filter math accelerator module in their microcontroller?
That's a good one. So we have some built-in filtering function in the ADC. That's part of the computational capability part. But exactly the wording, if it's exactly what Mr.
Ing.
Mr. Ing is looking for, I can't tell. But
Okay. No worries.
Something we can find out.
Yeah, no worries, Stian. And Dr. Ing, if you'd like to just reach out to livestream@microchip.com, we'll make sure to get you all the detail that you might need. So let's go ahead and just pose one more question here from the audience, guys. I know we're keeping you. We have Roberto on LinkedIn. How many other CIP are included in this chip?
Ooh, that's quite a lot. So we have. You're thinking of peripherals. It's yeah. So most of the peripherals can be connected and trigger events with each other. So it's hard to give a number, but again, reach out and we figure it out.
Okay, perfect. No worries, Stian. And Ulysses, thank you as well for taking the time to answer the questions. And to our audience, make sure to check out the description below to see those handy-dandy links that we had mentioned prior. And also, if we didn't have a chance to respond to your question, or if you're looking for a little bit more clarity, make sure to reach out to that email. We'll get you taken care of. And I want to remind everyone that they can follow us on LinkedIn, as well as liking and subscribing here to our YouTube channel to keep up to date on all of our industry trends from our experts here at Microchip. Back to you, Ross.
Thank you very much. And before we go into our wrap-up, I've had my producer screaming in my ear that this is season 5, not season 6. I've gotten ahead of myself. So if you felt like you had missed a series somewhere and you were panicking about that, not to worry. It's actually only season 5, not season 6. So with that, we will continue with season 5 over the next couple weeks. Upcoming, we have an episode on multi-channel power monitors, or I think, yeah, power monitors. But if you want to go check out all of our past episodes, you can go to microchip.com/coffeebreak, and there you will find all of the episodes to date. We were trying to count up before the show started on how many that is. It's approaching 30 episodes now. So do take some time. There's some great content there. Go take a look. This episode will be posted shortly, and all of the previous seasons are there. So do take some time and go rummage around. With that, I guess we're now down to thank you. So thank you to Ulysses. Thank you to Stian. Thanks to the crew here, Sean, David, Austin. Thanks for everything, as always. Thanks to Claudia for keeping me honest and screaming in my ear that it's season 5 and not season 6. And we will be back in a couple of weeks with power modules. And until then, stay happy, stay healthy, stay curious, and keep on learning, and have a lot of coffee. All right, that's it. Thanks.